So this paper, they are studying exploration versus exploitation. When there's a new ad, people don't know how interesting it is. So they should try, like the platform doesn't know. So they should show it to the consumers and see if it is a good ad or no. Um, and why they want to show it? Well, when you show the ad to the consumers, you as the platform are paid if the consumers click on the ad. So is this pay-per-click? Every time a consumer clicks on the ad, the firm or the one who asked for advertisement should pay the platform. So platform wants to show ads which are more likely to be clicked on. Also wants to show ads which the firms which their firms are paying more for the ads. So it's about the because they get a percentage of that amount. So it's like the product of how expensive the ad is and also how good the ad is, so that the consumer clicks on it. But platform already has some ads, and they know that which ads are good or bad. But once we have a new ad, we don't know how good it is unless we show it to the consumers. But if we want to show them to the consumers, we have to stop showing our previous ads for a while. So which is exploitation? No, which is exploration. We are exploring how good this new ad is, and once we get to know that okay, it is good or no, then we can exploit again the best of our ads. They study trade-off between exploration and exploitation, and they are modeling the problem as a multi-armed bandit problem. I like that it is related to reinforcement learning, a lot of learning problems, which I want to direct my research more toward them, learning. But now I don't want to read the paper. I read this paper before. Now I want to just make a slides, make some slides out of it, so that I can present it to my advisor. Okay, we have M advertiser. We have also a photo. I'm gonna crop it. And put it on my slides. So when we are on a search engine, mm, like there are these keywords or query phrase, and once somebody searches them, there are some advertisers who wants to send related ads to that query phrase. And we have a lot of query phrases. At each time there is a query phrase coming, and these advertisers compete for that phrase so that their ads is shown to the one to the person who searched them. Um, we have M advertisers. Let me add this. A1. So AIJ is the advertisement advertiser. AI submits for query phrase QJ, and we want to probably platform wants to see how good it is, and they pay BIJ for it. But is AIJ, how many query phrases do we have? I don't know. They can also have a daily budget, DI, that is the total amount of money is willing to pay for the clicks on its advertisement in a day. How many query phrase do we have in a day? Alright, doesn't matter. So the sum of Bij on J should not go further than the I. So every time the like QJ comes, mm, the platform chooses C, which sees the number of advertisers who win this auction, and they are shown to the consumer. Alright. Don't like that too many variables, but it is just good to have them all next to each other. Whenever we need, we can come back to them. So we have click-through rate, which is CTR of advertisement. CIJ, CTR of AIJ is the probability of a user to click on advertisement AIJ, given that the advertisement was displayed to the user of query phrase QJ. So once you are shown, what is the probability that your ad is clicked on? Because if it is not clicked on, advertiser won't pay. So platform wants to consider CIJ. Okay. Yes. So when there is no daily budget, mm, when there is no daily budget, the platform's revenue is maximized mm, by showing the ad with the highest CIJ times BIJ, which is the uh, probability that it will be clicked on, and then your your bid for the auction is high. And here we don't know what the CTRs are, and we want to explore them because BIJs we know, but CIJs as a platform we don't know them until we show them to the consumers and see if they are clicking on them or not. Mm. To maximize short-term revenue, the search engine should exploit its current imperfect CTR estimates by displaying advertisements whose estimated CTRs are large. On the other hand, to maximize long-term revenue, the search engine needs to explore, meaning identify which advertisements have the largest CTRs. Well, CTRs times BIJ. This kind of exploration entails displaying advertisements whose current CTR estimates are of low confidence, which inevitably leads to displaying some low CTR ads in the short term. Yeah, right? You don't know what is high CTR, what is low CTR. So you start showing the unknown CTRs. You find that some of them were low, some of them were high. So there should be like something like regret that says, oh, I used this algorithm and I showed a lot of low CTR, or I don't want to show a lot of low CTRs. How can I show these new ones. Multi-armed, multi-band, budgeted, multi-armed, multi-band. Unbudgeted, unknown CTR advertisement problem. Easier version. So their daily budget is infinite. I'm going to sleep. Ah, don't want to also present anything about the solutions. I just want to present the model. But it's one thing I want to present about solution. Okay, I want to mention this, that what kind of solution they're looking for here. For example, they're looking for an algorithmic method, and what is their goal? Is it like optimal revenue? No, it's not. They are okay. So policies are the solution to the problem. How we choose these ads, they're calling them policies, and we have different policies, and they are computing um, performance bound for any of these policies. So the metric is performance bound. Okay, UCB is very famous. They are considering it's a famous policy. What does it stand for? I don't know. UCB, University of California, Berkeley. So they changed it a bit and they call it MIX, which is Massachusetts Institute of X-ray, for mixing exploration with exploitation. Well, it is always the case, isn't it? So they propose it. Okay, what is interesting here is that like in my previous works, we had the problem and we were looking, what is the optimal strategy that maximizes revenue or maximizes. Here they're saying, okay, we propose this policy, it's not necessarily the optimal, and they say, okay, how good it is. So they have this problem, they know their objective, they propose a policy, they don't say it is the optimal, but they say how good it is. So they can be creative probably in our problems, we couldn't be creative in selling what is the optimal revenue. We should have found it. Here they're saying that, okay, I want this solution, this policy, and I will tell you how good it is. So first they're solving for unbudgeted, unknown CTR advertisement problem. And their policy is this mixed policy. So unbudgeted. Let me crop this part. Phew! So what is this policy mix MIX? Each time a query phrase QJ arrives, display C ads targeted for QJ that have the highest priority. What is priority? It's not CTR. The priority PIJ of ad AIJ is a function of its current CTR estimate CIJ hat, its bid value BIJ, the number of times it has been displayed so far NIJ, and the number of times phrase QJ has been queried so far in the day NJ. NIJ is the number of times it has been displayed, bid CIJ had, and NJ is the number of QJ queried. Priority PIJ is defined as if the ad is shown already, NIJ is positive, PIJ as CIJ hat plus square root 2ln NJ over NIJ. That square root term I think comes from UCB. Times BIJ. Alright. If the ad was never shown, it has the highest priority. And then second, monitor the clicks made by the users and update the CTR estimate CIJ hat, which is the number of times it's shown. Number of times it has been chosen, clicked on, over the number of times it is being shown. CIJ hat is the average of click-through rate observed so far, the number of times ad AIG has been clicked on divided by the total number of times it has been displayed. But what is the number of times it has been displayed? Okay, it is NIJ. NIJ is the number of times it's been displayed. So what is the number of time it has been clicked on? That we don't have any number for. So policy MIX manages the exploitation trade-off in the following way. The priority function has two factors, as we discussed. Exploration factor is square root 2ln nj over nij. How is it exploitation? It says, oh, it's exploration. It says if nij is low, if we didn't show it much, then show it more, right? And when nij is like 0, we show the priority is the highest, which diminishes with time. Why? When time goes, we show it more, nij increases, which diminishes with time. All right, and but nj increases as well. And an exploitation factor is Cij hat. Okay, if your estimated Cij is already high, which is Cij hat, we want to show you more. Got it. Cool. This unbudgeted constraint, it means that, okay, the firm says, okay, out of each click I make enough money, so I don't mind if you show me a lot, because I can make money out of that ad, and then out of those sales. And okay, there is one difference here with our model. In my model, we are also saying that there is this quality thing. Here the quality is in CIJs. In my model, we say we have CIJs, and well, that's good. We are not the same models. I want to learn how to establish this multi-arm bandit. The reason I started this paper, reading this paper, was it was about advertisement, which was related. So these two papers should not be the same, even though I feel now that they are very close. Okay, the case where the problem is budgeted, it is more challenging. And why? Okay, and we need a more complicated policy. Oh, what budget constraint does is that it creates dependency between, like, among queries, right? Before there it was unbudgeted, so each query phrase came it was not related to previous queries, right? We just compared their CIJ ads and stuff. But now if you want to show this advertisement for QJ for the next one, it changes our ability as the platform to show it to for the next query, because the person who is paying for the ad, the firm, may not be willing to pay because that's okay, my budget is met. Okay, they are called advertisers, firm. Budgeted multi-armed multi-bandit problem. BMMP. Interesting thing is that here we have no type space. Like CIJs are unknown, but nobody knows them. And they find it out them out by trying. Like in my previous works, the advertiser or the firm knew about its quality. So that's something I want to keep in my mind, and also it makes the problem very complicated in the auctions. And here there is no incentive compatibility, none of those stuff, no notion of equilibrium. I like it more, it's better, simpler the better. Okay, this budgeted multi-armed, multi-bandit problem. This is too complicated, and I don't need to present it today. I don't want to. So they also have come up with a policy for it. Who cares? Because I don't. The solution to this problem, the exact solution, it's not my study. What I want to learn from this paper is that how is their model, and more importantly, how they try to come up with a solution for the model. The exact solution, I don't care about it. What I cared about was that they have this policy and algorithmic solution, which was about exploration versus exploitation. That is important to me. And now they're finding performance bound for BMMP. This is all good, but not applicable to my problem right now. But I want to have my thesis at the end to have a solution like that, hopefully. All right, so I will finish the slides. I don't think there is much more to add to the slides. Just we want to mention what they did in the paper. Like they have this experimental setup, and they have graphs that says, okay, when we applied this policy, how was the performance and the revenue, and compared to other policies. And they also have a work on a real data set. That is interesting. I want to tell that to Munzer as well. Okay, see you.